Hey guys, welcome to Study at Home with the Professor. Today we're going to look at a new segment of IB Chemistry, which is Chapter 1, Stoichiometric Relationships. So today's video will be on Part 1, the introduction to particulate nature of matter and chemical change. So today we're going to look at matter, states of matter, elements, compounds, and mixtures. So let's go right into it. Matter. So matter is anything that is made of particles that are in constant motion, has a mass, and occupies a volume. So these three conditions have to be met for something to be considered as matter. So let's take a look at a few examples of matter. For example, rocks, smartphones, and us humans. Yes, we are also matter. Now, things that are not matter, for example, fire. Yeah, people say that fire is the fourth state of matter, which is plasma, but actually this is not the case. Let me explain why. Fire in its simplest form is basically light and heat energy, and energies have no mass or volume, hence it cannot be matter. So basically the flame we see is merely, how do I say it, a sensory perception. So that's why fire cannot be considered as matter. So let's look at the states of matter now. They are solids, liquids, and gas. That's simple. Now let's look at their properties. For the solid, fixed shape, fixed volume, cannot be compressed, particles vibrate in fixed positions, and the particles held very close to each other and also held tightly. So these five properties are basically what defines a solid. These are the main five properties. So now let's look at liquids. Now liquids have no fixed shape, fixed volume, just like solids, cannot be compressed like solids, but here the particles can move about and around each other, and the particles are held looser than in solids. Whereas in gases, they have no fixed shape, no fixed volume, and they are compressible. So the particles are able to move past each other at high speeds, and the particles have no forces of attraction towards each other. So just flying past each other, very high speeds. And now let's look at change of state. So from solid to liquid is melting, liquid to gas is boiling, gas to liquid, condensation, liquid to solid, freezing. And then from solid to gas is sublimation. So basically it's moving straight from solid to gas. There's no liquid state, and the opposite of that, deposition. So an example of a substance that undergoes sublimation and deposition is carbon dioxide. So basically when you cool carbon dioxide, it goes straight into solid state by bypassing the liquid state. So that's a very cool thing, you should check it out. Next, elements. Elements are substances made with the same type of atoms. So this is the basic definition of an element. So they include stuff like sodium, which is Na, iron, which is Fe, oxygen, which is O. They also include many other elements like gallium, which is basically a metal that melts in your hand. There are also others like francium, very, very explosive when you put it in water. A lot of things. There are 118 of them, and they're all found in the periodic table of elements. But I feel like in a few years, maybe the periodic table won't even look like this, because elements are being found all the time. Maybe not now, maybe not in a few years, but after that, maybe we'll find more elements. So now let's look at compounds. Now compounds are substances that are made of two or more different types of atoms that are chemically joined together. So compounds have different physical and chemical properties from their parent atoms. So they include stuff like water, hydrochloric acid, many things like that. And here in your screen in the center we see an acetazolamide particle, very difficult name. And in the right we see an adrenaline particle. So all these, however complex they are or however simple they are, like just look at the H2O water, it's really simple. So all these are compounds. So here's a small tip. this is a chlorine molecule, and it's actually not a compound. It's because a compound has to be made of two or more different types of atoms, and in this case we have two chlorine atoms. So that's why it's considered an element, not a compound. Okay, now we'll take a look at isotopes. Isotopes are atoms of the same element with different number of neutrons. Now that's the basic definition. Now, a point to note is that they are often mistaken to be compounds, alloys, or mixtures, but they are classified as elements because they are still atoms of the same element. Then let's take a look at an example of isotopes. This is a classic example of hydrogen. So the isotopes are protium, deuterium, and tritium. So as you can see here, the only difference is the number of neutrons. The rest stay the same. So that's why they are of the same element. Now let's take a look at mixtures. Now mixtures are substances made of the physical combination of pure substances. So basically two elements put together in a way that they can be, removed, two compounds or an element and a compound together. Anyway, anything pure put together forms a mixture. And because they are physically put together, contents making up the mixture can be separated back to its original forms. So we can use separation techniques like distillation, chromatography, filtration, evaporation, and many others. So now let's take a look at examples of mixtures. They come in two types, homogeneous and heterogeneous. So homogeneous mixtures are mixtures having a uniform composition. Now in layman's terms, uniform composition means that all the stuff making up the mixture is distributed evenly. So let's take a look at some examples. For example, seawater is homogeneous. Also alloys, for example, this in the screen here is stainless steel. That's also a homogeneous mixture. Now the other type is heterogeneous mixtures, which are mixtures with a non-uniform composition. This means that all the stuff is distributed in a non-even fashion. So examples of that would be, for example, a salad or paint. So that's it for today, guys. See you next time. Hope you enjoyed the video. Please like and subscribe and feel free to comment. The professor will be back.